Hello everyone, this is a video lecture for Business Calculus 1325, section 12.2, integration by substitution. U sub is basically what we're talking about, U sub or U substitution. This is a big topic. And, you know, I contemplate the difference between this class, this business calculus class, and our regular Calculus 1 class. And, like, what's the difference here, you know? For y'all, I got to say, this stuff is fast. We're just hitting it. U sub, I believe, actually starts in Calculus 2. No, it might be Calculus 1 still for us, but it would be for the other guys. But it's like these topics come up so fast for us, and like you'll be zooming by and I don't know, blah blah blah. Anyways, we're gonna do it nonetheless, and this is a really big section. I'm just kind of prepping you that, like, you know, we just saw what integration is, and boom, I'm gonna hit you with something hard. So it's fine. It's gonna be great, man. We're gonna do this together. So what is U substitution? So first off, I want to show you a dilemma we have. Okay, we have something like this. And it says, go, figure it out, plus C. So the problem here is that we have a complicated inside, making this whole thing really difficult. And if I actually wanted to expand this, like FOIL it out, then I would get a lot of these. I mean, there's 5 of them side by side. So 2 times 2 times 2 times 2 times 2 to the 5th is like a lot. I didn't even have this in my notes, so I'm just kind of like tossing it out here. I think it's like 32. So like if you actually wanted to do this, it's like 32x to the 5th plus blah 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 dx, and then you find the integral. Oh my gosh, please don't do that. No. So what U sub is going to do is make this a lot easier for us, okay? What we're going to do now is say u to the 5th du. That's easy. We've already done this. 6 power divided by 6 plus c, of course. So you just add it into power, divide by a new power. Done. Well, that was easy. In order to do this, though, we need to have said that u was equal to 2x plus 3. As in, like, we need to make a substitution here. Okay? But in order for us to even do anything with this, we have to find a du as well. Notice that I went from a dx to a du. And that's the easiest thing to forget when you're going through these problems. And so I'm going to say if I had a u, then I have to find a du as well. What's the derivative? D means derivative, right? This is 2. But because this is implicit differentiation, oh, you totally remember that, don't you? Implicit differentiation, we're going to have a dx there. This is not where I stop. I continue on. I do more. I say, you know what? This is not a very good formula. I want a dx formula. So I divide by the 2 on both sides to get du over 2. I basically just do this. Knowing that I have this and I have this, I can actually do what we just did here in a way. So let me now do the whole problem. Let me actually show you what this problem would look like from the beginning. In a way, I'm showing you all the pieces, all the little nitty-gritty things that I'm going to have to do in order to get this problem to work. So let's start over from the very beginning, brand new and fresh. I'm like, okay, whoa, that's complicated, Chad. I have a complicated inside. And so instead of having to deal with it head on, I'm going to say, well, let's do a substitution thing. I'm just going to call it u. And so if I did that, now I'm also going to have to change this dx. So I need a du kind of in order to make this thing work. And so I'm going to say the derivative of this thing is a 2 dx. Again, that's implicit stuff. X goes to dx. I'm going to divide by 2 on both sides. And so then I get dx is equal to du over 2. This and this, I literally plug in right here. I'm going to plug them in. Here we go. So then I have 2x plus 3 is a u. That's still to the 5th power. Hold on, dx. Hold on. Do I have a formula for that? I do. It's right here. du over 2. And so, like, if you could see what happened is that this was not actually what was going on in the end. I had to, like, change this. I had to do more here. So it didn't actually end up like that. And that's my point, is, like, we don't really know until we start doing it. There's a 2 there. And technically what that is actually a half. And this half you could put in the front so that it looks more like this. And this is a lot cleaner now. So I took that half and I just moved it over there. I didn't actually divide. I didn't actually multiply. I just moved it. So it looks like this now. And so then I'm going to say, well, what's the integral? I'm going to add 1 to the power and divide by the new power, plus c. And what I'm left with now is this guy, which sounds awesome. Yay! But no, because they want x's. They started with x's, now you have to get an x answer. It's a good thing we have a formula for that. You see how I'm going to just plug it in now. So like, here we go. I'm going to now plug it back in. I got now the 2x plus the 3, now to the 6th power, all divided by 12, plus c. This is your answer finally. We finally got it. So that's u substitution. The second section in your calculus, like integration calculus chapter, is this. And it's tough. But it's something that we have to do. And so let's go. Like, that's okay. That's why I'm here. That's why we're doing the videos. And I do a lot of the homework. I really do. By now, you know that. I don't do it all. You need to, do it some for yourself, of course. But I'm trying really hard to show you what to do. Okay. They say do this. Go. And immediately we were struck with the fact that I need a new formula. And that's kind of how I roll. I mean, this is how, how I do this. Whenever I'm faced with a new challenge, I'm like, well, what do I do? And so the integral of e to the x dx is equal to e to the x plus c. Just like the derivative of e to the x is e to the x, same as the integral of e to the x is e to the x. But I don't have this. I don't have just that. I have something else. So I have to do a little bit more math now. So let's say that I have u is equal to 10x. du is equal to 10 dx. One step further, dx is equal to du over 10. And I'm going to plug it in. So e to the u times 10. It's very weird how they had that 10 sitting there just for no reason. I don't really know why. Blah, 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 blah. Oh, yeah, du over 10. See it? I cancel. So they did it on purpose so that you would get an easy integral. What's the integral of e to the u du? Oh, it's right here. Look, we just did that. It's e to the u plus c. Hey, I have to go back to x's. So what is that u equal to? Oh, yeah, boom. It's right there. Plus c. We're done. What they're trying to do with these problems, this one and the other one, is they're trying to handhold it for you. And to me, honestly, between me and you, it's very annoying. It's very annoying. I'd rather them show me honesty rather than trying to hold my hand and say, well, we're giving you easy problems. Isn't that nice? It's not really that nice, honestly, because they're only going to get harder and they're not going to hold your hand the whole time. So this is the next one. What the heck is this thing doing out right here? What is that? Oh, it's a derivative of the inside. They're trying to show you a different way than what I'm teaching you. If you do the help me solve it, view an example, anything else, you go to a different professor, you go to a different teacher, you go online, they're going to say, oh, yeah, all of this is your du. Yeah, okay. That's fine. It's not going to help you later. It's not going to help you later. I'm not going to teach you that. I'm not going to go down that road, okay? Because this is a hand-holding question. I'm not going to go down and let them do that for you every time. It's not going to happen. Don't succumb to that. You see, this is a complicated inside, okay? Ignore all this. It's not going to be there in the future. And then what are you going to do, right? You're going to do what Chad told you to do. Complicated inside. Take the derivative of it. So we get a 6x dx. And then I'm going to divide by the 6x on both sides. Basically, I want dx by itself. Du divided by 6x. This and this are what I'm going to actually use. So here we go. I'm going to say integral of the square root of u. We still have a 6x squared, I don't know why, times du over the 6x. Squared? I messed up there. Look. The 3 makes a 6, and then squared. I brought the 3 down, forgot the 2. I forgot the 2. I'm so sorry. I mean, you should have seen it coming, right? Come on. I'm sorry. That was totally my bad, okay? Right there. I'm trying to make a point, and then all of a sudden I make a weird. Cancel. I mean, like, yeah, great. So we're left with this guy, which, because it's the square root, it's actually a half power. I add 1 to the power, and I divide by the new power. And that'll become more second nature the more you do this. Like, I'm thinking back to that very first video I had, like, at 12.1. And, like, for me, it was just, like, a couple minutes ago. And it was, like, crazy. It was, like, crazy. Like, what is he doing? Well, that's just, you know, it is what we're doing. Replace the complicated inside. You see that u? It's going to be replaced with this guy right there, that 1 plus 2x cubed. And now to the 3 halves. And still plus c. And now we're done. Yay. Do not succumb to what they are pushing. Don't do it. It will only hurt you in the future. It truly will. So here we go. Here's another one. This one at least is not as hand-holdy. They're tossing it out there and hoping you catch it. Well, that's why I'm here to do it for you, with you. So the complicated inside is going to be the denominator. Basically, it's the stuff that looks weird and I don't want to mess with it. Like the x cubed looks more friendly than this stuff. And so my derivative, the 4 comes down to make an 8, x cubed, dx. And so dx, again, I'm just going to divide all that to the other side. So we got this guy right here. And again, this and this are going to be very important when I substitute back in. So I got an x cubed over u, and the dx is now turned to du over 8x cubed. Cancel. Okay? I'm telling you, other teachers are going to look at what I'm doing here and go like, rah! And they just don't like what I do. You can't mix x's and u's. Okay. Well, I'm doing it, and it's going to work, and it always works. So there you go. So integral of 1 over u, and we've already seen this. I think that was on the last section. It's the ln with the absolute value signs and then plus c. All these formulas. And so then I don't want a u anymore. I actually want to go back to the x's. So 4 plus 2x to the 4th. And then plus c. There you go. We did it. Whew. Keep cruising, man. Keep cruising. We got 12 to 40. I mean, this is a big section. We got a lot to cover here. I love doing these problems with you. I think the last one, it was fast, but it was also kind of easy. Just repeat yourself again and again. All right. So this one's easy yet again. I'm going to say the complicated inside is right here. And so I'm going to scroll a little bit and say my u is equal to p plus 4. Du is equal to dp, pause. Pause. You see, these are actually the same, which means I could plug it in directly. So I got p times, and I got a u, and then I got a 4. That's a 4 up there. I know u's and 4s. And then dp has now turned to du. Oh, hold on, Chad. Hold on. I still got a p. It didn't cancel. What do I do? Yeah, I know. Normally it cancels, right? So there's got to be a way out of this. What about right here? What if I said minus 4 on both sides? I know it's an odd thing to do. But couldn't I do that? And then replace it? And so what I have now is a u minus 4. And then I have another u to the 4th du. Whew. U's and 4's, man. They just had to do it. Just had to. Well, the best thing I could do right now is going to be distribute. And so then I got u to the 5th minus 4u to the 4th du. I'm going to use parentheses because I'm a very picky person. I'm going to integrate both of those. So add 1 to the power, divide by the new power. Add 1 to the power, divide by the new power, plus c. Just adding 1 to the power, divide by the new power. Same thing every single time. Oh, wait, I have a u. I know what u is. I had a formula for that, right? It was right here. This guy. P plus 4. So every time I see a u, I'm going to now say P plus 4 to the 6 over 6. P plus 4 to the 5th over 5. Plus C. Still don't know what C is. That's it. We're done. All right. Now for the ultimate hand-holdy, very upsetting problem. After this, things are okay again, I think. I hope. Yeah. Just looking ahead. A little bit complicated, but this one here is so annoying, at least to me, because they force you to do it their way, and I don't like being forced into doing things their way, okay? I just don't. And they had to choose something so easy. Timeout. Let's just say that I wanted to do this in 12.1 without this whole U sub stuff that I've been showing you, right? Bro, this is not hard. Distribute, right? And so then you got a 25x plus, 45? Bro, I got that. It's not a big deal, right? You're still going to add 1 to the power, divide by the new power. I add 1 to the power and divide by the new power, right? That was a 0, now it's a 1. You don't have to do the 1s, of course. Plus c. So what? We got 25 over 2, x squared, plus 45x, plus c, and we're done. We did it. It's not a hard problem at all. This is a 12.1 problem. This is nothing wrong at all. And this is part B. Yeah, that's part B, but if you try to put that in part A, they're going to be all mad at you. That was me sighing, by the way. So what do they want? They want you to go down the worst and the more confusing road for no reason. They're saying, oh, well, it's a complicated inside. Just listen to us, right? We know what's going on. So that's a 5 dx. I'm still going to do it my way. Keep going one more step. So then I got 5u du over 5. Right? And the 5's cancel. Integral of u du. So remember that this was a 1 power, right? So I'm going to add 1 to the power, divide by the new power, plus c. And then I'm like, oh, well, I know what u is. It's 5x plus 9. And I'm going to square it, divided by 2 plus c. This is what they want for part A. Now, is that a pretty answer? Sure, it looks pretty. Completely useless. Something like this is way better anyways. This is easy calculus. This is not. Part C. They say, are they equal? Are they equivalent? And you're going to say yes. And there you go. All right. So now you know. I get picky. I'm sorry. That's just who I am. 12,261. So I got integral x square root of 8 minus x squared dx. Okay? Let's say figure it out. So complicated inside. U is equal to 8 minus x squared. Du is equal to negative 2x. Again, the 8 goes away. 2 comes down. Dx, it's implicit. Ugh, got to keep remembering that stuff, right? It's not too bad. I know, but you have to do it. You have to do it, okay? It's implicit. It's just part of it. So I'm going to be able to plug that in now. And then du over negative 2x. Now, what happens here is that the x's cancel. that 2 can come to the front. So now I have a negative 1/2 in the front, u to the 1/2 du. So I'm going to add 1 to the power and divide by the new power, plus c. What happens here is that the 2 comes up to the top and it flips, basically, and the 2's here cancel, leaving a negative 1/3 u to the 3/2 plus c. Well, I know what u is. It's right here, this guy. So I got a negative 1/3, 8 minus x squared to the 3/2, and then plus c, and there we go. Was that it? That was it. Awesome. Okay. Cool. So I got like a price thingy, a price kind of problem. Wow, it's a pretty big problem actually. And then I got something about E. I don't know what E stands for. Can't remember. Anyways, we're gonna do two more problems, but they're really big ones. They're like word problems. So let's talk about it, okay? 12,277. So they got P prime. So the rate of change of price, I guess, is a negative 9,000 divided by 3x plus 50 all squared. Who comes up with these formulas, right? And then they say, what is P if x is equal to 150 and P is equal to $2? I mean, yeah. So you're selling 150. The price was $2 each. Blah, blah, blah. There you go. So that's going to be that whole like find plus C business. So I'm supposed to integrate this thing, right? We're going from P prime to P. That's an integral. Dx. It's a dx because there's an x in there. Well, we have a complicated inside, right? So yeah, let's do that. So let's say that u is equal to the 3x plus 50. Du is equal to 3 dx. The 50 goes away. And dx is equal to du over 3. So now I got the integral of negative 9,000 over u squared, and then du over 3. Well, the 9,000 and the 3 mush together, and you can put them in the front as a 3,000. And this u to the 2 down there is a negative 2 because it's in the denominator. Well, now I can integrate that. So I'm going to add 1 to the power, divide by the new power, plus c. So 2 negatives cancel, make a positive, and technically that u is just like stuck in the bottom right there. Well, I already know what formula for u is. It's right there, 3x plus 50. And then plus c. So in order to find the plus c, I'm going to go and plug this stuff in. So 2 is my answer whenever I plug in 150. So 2 is equal to the 3,000. And I'm going to plug in the 150 plus 50 plus c. And then we're going to solve for c. So 3, you know what? Calculator. 3 times 150 plus 50. Oh, the whole thing's 6. How convenient. Minus 6 on both sides. So c is equal to a negative 4. I'm going to check my notes. I don't want to go too far, mess it up. Yeah, that's right. That's right, we did it. So my P, I guess, my final answer is 3,000 divided by 3x plus 50, and then minus the 4. And there you go. We just did it. That was part A. Oh, no. Hold on. They actually need you to type the P equals. I have a little note here that says the P equals is required. So I have a note there. Okay, so watch out for that little guy, okay? You have to type the P equals also. For part B, they say find the demand for price equals $5.50. So P equals 5.50. They say find demand, as in like X equals something basically. Well, that's just you solve. And so you're saying, there's my formula. $5.50 is equal to all this stuff here, solve for X. This is not hard, right? Move the 4 over. Like, add the 4. I was about to like minus 4. That would have been bad. Oh, it's not 150. It's just 50. I'm going to multiply here and divide. I mean, all of this, I could probably use Desmos graphing, but we've already gone this far, right? Let's find out what this guy is. Fraction? Okay, I guess. I'll take it. I don't know. And then I'm going to minus 50. And then I'm going to divide by the 3. There's my x. 6,000 over 19 minus the 50 all over 3. Here we go. What I'm going to do is A&S, answer. Like pulls up the last one, by the way. Makes it a little bit easier to type things. And there you go. I got 88.596. That's what they want. That's their answer. I don't know, units or whatever it is, demand. Awesome. Cool. One more problem. So this is 12,291. Sweet. So I got DEDT is equal to 6,000 T plus 16, and then all to the negative 3 halves. And they say at T equals 0, we also have E equals 4,000. Now, this is a word problem, and I honestly cannot remember it. They're saying find E at 9. I don't even know if they care about anything else. That's a 9. They're saying plug in 9 at the end. But we have to do the whole thing in order to get the answer anyways. Well, without too much theory, and I mean, I know you've already seen this, but if you integrate both sides, blah, 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 and you have to like move this over to make it look like a blah, 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 you're just integrating. You're just integrating, okay? I mean, I think the theory behind it is cool, and sometimes it's like really applicable, and that's why I stop sometimes to do that. But like here, I'm just saying, hey man, integrate both sides. You got your derivative. This is E prime. How do you get rid of it? You integrate it. It's like the opposite. You're going backwards. And, well, you're in section 12.2. What else are you going to be doing to this thing, right? So U is equal to T plus 16. DU is equal to DT. Pause. Again, this is a 1, right? So there's a 1 in the front. Doesn't really change anything. So that's kind of interesting. It happens sometimes. So then I got you know what? I'm going to put the 6,000 in the front. 6,000 in the front. Integral of U to negative 3 halves du. I'm going to add 1 to the power and divide by the new power. So that's actually going to be a negative half. The negative half, the 2 comes to the top. It actually makes this a negative 12,000. And then it's divided by the square root of U, essentially. It's like half power. And I knew what U is equal to is this thing right here. So T plus 16 plus C. Now, they told me that right up here that at 0 I have 4,000. Most of the time, you can just say, oh, well, T equals 4,000. But I don't think that's going to be the case here. So I want to actually do it. So 0 plus 16, and then plus the C. Well, the square root of 16 is equal to 4. What is that, like 3,000? Negative 3,000. Move it to the other side by adding. So I actually get C is equal to 7,000. So here's my final formula, I guess. This thing divided by the square root of T plus 16, and then plus 7,000. So this is awesome. And yet we're not done because they want to now find E at 9. So I'm going to plug in a 9 now. 9 plus 16. Isn't that a 25? It's the square root of 25 is a 5, essentially. Calculator. I get lazy once in a while. There we go. That's what I got to on my notes. There you go. That's the final answer for your E thingy. Okay, cool. Whew, lots of stuff there. So, I know that I'm not doing as much theory as I probably should, and I can do more, but I mean, really, this is business calculus. You're going to see it, you're going to use it, you're going to move on. Just like I recommended at the end of my other videos, I mean, I got a U-sub video in Calculus 1, and I go in a lot more depth there, of course, because it's like a calculus class. You're going to be seeing that a whole lot. But this is a terminal class for you. You're not going to see this stuff again. I mean, unless maybe you take another business math class somewhere. I don't really know. Anyways, so if you want to go and see other stuff, check my other YouTube videos. But here, we're just doing it. We're just doing it. Thank you very much. Have a great day.